I got asked a couple times recently whether we sell floor plans for high performance homes, and I am not an architect. I will show you a couple of the floor plans that we created that we then showed to architects and said, here, fix whatever's wrong with this. But I'd like to show you floor plans that I think are brilliant for certain reasons to do with performance, so that you can take those ideas, not necessarily the floor plans themselves, because like every home should be different. I think that that's useful. We'll start with the Tiny Lab. This is our high performance tiny house on wheels that we lived in for 5 years. This is what it looks like in real life. We built this. We built the plans ourselves. It took us about 9 months to a year to plan the thing. And we had to engineer this in very special ways. When you put a tiny house on wheels on the highway, you're putting it through basically an earthquake and a hurricane at the same time. And we did that for 13,000 miles. So this thing is built like a tank. I edit these videos in that office right now. We haven't lived in there for a while because it was a temporary. We lived in there for 5 years with 2 cats, 2 adults, and 2 kids by the end. And it was pretty tight. So this is what the floor plan for that looked like. And I'd like to just show you the first basic level of circulation that I came to when I was designing this. It was very important to me that we have, obviously, spot exhaust. And when we talk about the 5 factors for ventilation, we got circulation. So we really wanted to handle that in this tiny space, make sure that air is moving around within it. Capture, which is what the bathroom and the kitchen are for. Humidity control, dilution air, pressure relief. You can see that in this plan, the bathroom is at the far end, and the kitchen is right next to it. And that's both for plumbing and also for the exhaust. So we were going to exhaust over the cooktop and exhaust from the shower. The toilet technically also has a little tiny exhaust built into it. It's a composting toilet. And I've got a video about composting toilets if you want to see what that's like. And then at the other end is where we live. So the dining booth up top and then the sleeping loft underneath. And you can see here, there's the dining booth with the 2 seats and the table that folds out. Underneath this, which is up a small set of stairs, underneath that is the sleeping loft. And so we wanted to have fresh air supplied, just like any home, to places that you're sure you're going to spend a lot of time in. Bedrooms are a classic example. So if you're thinking about delivering fresh air, deliver fresh air to bedrooms. That's brilliant because you're going to spend 8 hours a night there, hopefully. And then also to the dining loft, which is also where we would set up our computers and work when we had time to while we were on the road. And then air would flow from this positive end of the house all the way over here and get exhausted from the kitchen because of the kitchen exhaust. That's the only one-way exhaust that existed in this house. And the ERV extract, which was over the shower. So this one-way flow of air really solved a lot of things for us. And I will tell you that I had to design 4 ventilation systems to get this thing right finally. I went through Panasonic, Zender, went back to Panasonic, and then settled on a Broan ERV before they had the AAI. It was the smallest one that they could make. There was a 70 CFM. And for tiny homes, that small amount of airflow is very important. Let me show you another tiny home. This is not one that's on wheels. This is an actual ADU that's from a friend of mine named Vic. And this is an awesome plan. He did not know how awesome it was until he showed me. So we've got this really cool vault with this very huge overhang. We've got the bathroom being in the lower part of it, and then the kind of main living space. I like what this person is doing. It looks like a dance move. So in this floor plan, what is so cool about this is that we have a flow, just like we have in the Tiny Lab, where it's from one side to the other, which is the same as in the room that I'm in right now, by the way. The studio in my house goes from one side to the other. I'll show that at the end. This one doesn't have a straight line. What this one has is instead a circle. So we have magically, the architect did not do this on purpose. This architect is really cool. I really like working with him. We've had several meetings so far trying to perfect this HVAC system. What's brilliant about this is that we can introduce air in the bedroom so that now the bedroom contains the freshest air in the house. And we can circulate it around in this circle and then subtract it from the bathroom inside the shower. And that air will have essentially impacted every single space. Here, I've kind of waved it, and my point there is ceiling fan. In that big, tall room, you definitely want a ceiling fan in there. So the air that's coming out of the bedroom will mix around in this room and then be drawn back and to complete the circle. That's awesome. And in fact, when we drop the ceiling over this bathroom and then drop the ceiling over the bedroom, which I think that they've actually opted to sneak out and around with ductwork, we can also introduce the conditioning into this room, and then return the conditioning from this side. So we've got the ERV and the filtration and the conditioning, the heat pump, all following that same circular pathway. And I think that that's very, very cool. If you're looking at a small home design, think about doing that, because that is always something that's very useful. It's when you it's just like bathrooms, right? I have a video about bathroom design. If you can put the toilet between the door and the shower, it works better every single time, because the air goes in and it passes by the toilet on the way to the shower. You get a 2-for-1. When you start putting the bed over there in the corner and then the bathroom and everything, it's like gets real complicated. So anyway, I really like that. Here's a slightly bigger house. I made an entire video about this floor plan that was in a home that was affected by the hurricanes. And what's brilliant about this plan, aside from the fact that it's very compact, and some people who like compact floor plans are going to be like, yay, it's great, is this. This is a central hallway, which we can use to deliver all kinds of cool things. We got those 5 factors. Circulation, we can circulate the air from there. Capture and filtration, humidity control, dilution air, pressure relief. We can do almost all of these from this either dropped ceiling or what's called a reverse soffit, which is a raised portion of the attic up into the attic that then we can air seal and insulate over the top of. So if we were to just do that, we could deliver all of those factors of ventilation to each one of these rooms because we can get at them. That's brilliant and also accidental. Like a lot of times people are not building a house that's shaped like this. A rectangle is, when you've got a square lot, people think automatically square house. Square house has some problems because there are a lot of rooms inside of it that are going to be loadless, meaning they have no exposure to outside. In this house, every single one of these rooms has an exposure to outside, which means that every single one of these rooms gets a supply of conditioned air. So if we're building an interstate highway through the house with one central duct system, even if it's a small duct system, and in this case, the video that I made pointed out that I was talking about a ducted mini split. So it's a very small duct system. Even then, we can deliver everything that we need to all these houses, all these rooms. Here is an example of a home that has a little bit of a problem. This is the first floor of a multi-story home, and I'm going to show you how we saved this. This was the first iteration of one of my friends, Tony. He was kind of messing around. He had found a floor plan online. And this often happens, by the way. If you're out there looking at floor plans, if you're asking people like me, not an architect, for floor plans, you're definitely out there just Googling floor plans. And you might come across one that you're like, ooh, I like it. Trying to fit performance onto a floor plan is pretty difficult. And I'll show you, again, my forever home with Grace that we designed that started from thinking about performance and kind of what that leads you to. And hopefully it would lead you to a slightly different place than it led us, because every home should be different, like I said. But the problem here is that we've got this entry foyer. You can see it says 2-story cathedral ceiling, which leads to a great room, which also says 2-story space with cathedral ceiling. What we have here is a giant red flag that is separating the two sides of the house. So now I cannot get ductwork from this side of the house over to this side of the house. And now we're locked into basically 2 systems. We're saved by the fact that this house has a basement. So we can get at both of those sides from below. And now all we have to do, and this is bothering me, I'm going to take that away, is let's do this instead. All we have to do is figure out a chaseway that we can use, a shaft essentially, to build into the house, which over here is pretty easy. We can steal it from the laundry. We can steal it from the office parlor. Even way over here in this walk-in closet if we wanted to. Over here it gets more difficult. We're going to have to steal something from something that's probably valuable, and we've got all this space that looks pretty, squared off. We're going to have to be bumping out, and some people get really upset by that. So if we've got this basement, we would want the utility room, and this happened in later iterations of Tony's plan. We moved the utility room to a more central location. what my buddy Alex said in a recent video is it's called central air, not corner air. The more in the corner you shove your HVAC systems, the harder they have to work to get the air all the way across the house. If you put this thing right in the middle, you split it immediately. That basically cuts the resistance in half of all of the duct system that branches off from it. So this is one way to fix that, is move the utility room more central next to the staircase would be great. Now, also on the top floor of this, Tony started out wanting to have a vented attic. Vented attics are a great idea. In fact, I have a video with Matt Reisinger where I try to sell him that a conditioned crawl space is always better than a conditioned attic. And at the end of that video, he agrees with me. Not spoiler alert, but he can't do conditioned crawl spaces because of where he builds. So essentially, if you can do this below area, the basement, then great. You don't need a vented or an encapsulated attic, because you can carry stuff through the basement to get it up there. In this case, we're going to save a lot of money by not spray foaming the roof plane. We could just blow insulation because gravity goes down. We could blow 2.5 feet of insulation. Really easy to air seal all this. And we happen to have in this plan this beautiful, same exact central hallway. Again, rectangular layout. If we put either a reverse soffit up into the attic, which is totally possible if this was stick framed, which means you're using dimensional lumber, not trusses in the attic. If you use trusses in the attic, this becomes more difficult. You could still do it, but it's just like, you got to get around a lot of wood that's going on up there. So in this case, we can raise the ceiling and we can get up into the attic and we can deliver through ceiling registers into every single one of these rooms, each of which has a load again. We don't have any little orphan rooms that don't have a load. Or if we had to, we could drop the ceiling in this hallway and we could introduce air from the high on the side wall into every one of them, right? So basically right up by the ceiling, you'd come out of the wall and you'd be able to deliver air to every single one of these. Now here is one example of why I really like ceiling fans. If you had a ceiling fan in this room, you can deliver the air literally right on top of the door, and the ceiling fan will grab that air and make it go to the other side of the room. Otherwise, if we don't have the ceiling fans running, I'm going to deliver air up here, and maybe it's a mild day and your HVAC system's not running that hard. It's going to just poof a little bit of air in over here. The bed is way over here. The air is going to turn around immediately and want to go out through the undercut on the door. It's not going anywhere close to the bed. And in a high-performance home, remember, we're using that interstate highway of ductwork, that one ductwork that connects every room, to deliver not just conditioned air, but also fresh air and humidity-controlled air. And all of that you want to be passing by your bed on its way outside. So if it leaves the room before actually going into the room, that becomes a problem. So here is the last thing that I'd like to show you. This is our home. Our forever home in Atlanta. We designed this thing and then we gave it to our friend Jody Lomer-Giddens to say, like, hey, we're not architects and I want to make sure that this makes sense, that the hallways are the right sizes and we left enough room for toilets and all this stuff, because we were just building boxes basically. Part of the reason that this is so simple looking is because I was going to build it with my mom and dad, and none of us are builders, and I wanted to make sure that I had a simple shape to work with because I know how to build simple shapes, so I could do that. The two things that I'd like to point out to you is, number one, where in Tony's case, we had this central great room, and this is a very common thing in a lot of architect-designed floor plans. You have the central space be central in the social life of the home, and it's like in the middle of the house. That becomes a problem because now we can't put a shaft into the middle of the house. And the shaft that I built into the middle of our house is dead middle of our house. Goes right up from the crawl space up into the second floor ceiling. And by the way, the house looks like this in case you are not familiar with it. So it's what is technically a monitor barn style. We did not know that until we had actually already designed it. And then we were like, oh, there's a house shape that's called that. It's called monitor barn. So basically, 2-story section here in the middle, 1 story on this side and this side. I am speaking to you from this room right here, and I'll get back to that because I'm going to circle back around to the tiny spaces thing. But over here is our main living space. You can see not central at all. It's on the side. And we have between 10-foot ceilings here and 16-foot ceilings here where the stairwell goes up. And that's a really nice big space. And it doesn't have to be in the middle of the house. So just take that under advisement, because now I can deliver air. It's not in the way. I don't need to pass through that space to get air anyplace else on the other side of it. That's really good. I have the crawl space underneath it for things like makeup air for my kitchen exhaust, which is over here, for plumbing, for water heating, all that stuff. And the shaft really enables us to do this. I actually overplanned the shaft. This is, as you can see, about 5 feet long and maybe only 1 foot deep. Is that what it says? I think that's right. And that is so big that actually I didn't need it for all the ductwork that I need to run up to the second floor. My dad built a ladder in there for me out of 2x4. So I can climb all the way up through my house from the crawl space to the very tip top of the house through that little shaft. I think that that's pretty brilliant. One thing that I would say real quick, spoiler alert, when we do our update, our 4 or 5 year update on this house, is that this laundry room is also central, and I would have insulated the walls of this laundry room. Not because of the laundry, but because the water treatment stuff is in there. Those water filters have a backwash cycle that is insanely loud. And if you program it like most people do for the middle of the night, that thing is going to scream at you at 4 a.m. We've figured it out now, and we've gotten used to it also. But this tiny space over here, which is what I'm talking to you from, I just wanted to point out as well. When I first designed this, I did it wrong. This is not where this thing should be. We need to take this room and move it out of there. We got to bring it down here. This is the correct place for the bathroom. So what's in this room is a bathroom. And the reason is that we want to subtract air from one end of the space and supply air to the other end of the space. This happens to be where the door is, and so this air will be the most humid potentially. So the dehumidifier was installed right here. The dehumidifier intake now, I used to have an in-wall dehu, and it's bit the dust a couple years ago. This one right here, though, is the intake for the dehumidifier, so it's drawing from probably the most humid place in the house. This entire space has its own conditioning and ventilation and dehumidification and filtration system. And by the way, I've got 3 duct systems in this crawl space because I have a ductless mini split feeding heating and cooling into this room. So just consider all of that as you're doing this. Think about the 5 factors, again, just to review: circulation, capture and filtration, humidity control, dilution air, and pressure relief, and try and find ways to deliver all of that to each one of the spaces within your home that needs it. Some of these interior rooms, like for example my walk-in closet here, doesn't have a load. It's what I call a loadless room. Therefore, we don't need to deliver heating and cooling to that room. If we did, it would be overheated in the wintertime and overcooled in the summertime. But we do need to figure out ways to get all of this ductwork in here. Now, the one last thing that I would point out on this plan, which is something that I have pointed out before, is that I wanted to have no floor registers in my house. I also wanted to have no wall outlets on exterior walls. So for example, along this wall right here, where you have to have wall outlets every 8 feet per code, we did floor outlets instead, so that I wouldn't put electrical and outlets in my walls, because my walls were for insulation and air sealing only, and water control obviously on the outside. But the other thing is that I didn't want to have floor outlets of air. I didn't want to have floor grills or floor registers. Largely because gravity goes down, and I have 3 kids, and if they drop a crayon or drop juice or something, it's going to go inside my duct registers, and I don't like that. So I wanted to get the air off of people, because the number one rule in duct design is to not blow air on people. And one of the main ways you could do that is by getting the grills up by the ceiling. And we've got 9-foot ceilings in the central space here. We've got between 10 and 16-foot ceilings here, 9 foot here. Again, this is another big room that is the exact mirror of this one. So what we ended up doing was going up through walls. And this was really easy in the bathroom. I drew from underneath the stairs. We've got the central return right here underneath the stairs in this kind of cavity. I'm drawing the toilet exhaust from the wall right here. If I need to supply air to this room, then I need to figure out how to do that. And that was a big conundrum for me for a while. I ended up doing it in 3 places. One is soffitting right here, up, and then pushing air along the wall. And you take advantage of something called the Coanda effect. Also, when you take air up and deliver it near the ceiling, it glues itself to the ceiling. You can also glue it to a wall, and it travels 30% further into that room by gluing itself to a surface, so that it's not just poofing out into the middle of a bunch of air. I have a second soffit here where we've made this a diagonal. I take this all the way up to deliver by the wall and by the ceiling, and it travels down and through the room. And then another one that's over your head as you travel up the stairs. 3 vents for this gigantic room. It's more than enough. Do not worry about that. I have clients sometimes who are like, I want more vents. And what happens, of course, when an HVAC designer adds more vents for you is that they just cut the output of the 1 vent that you just made into 2 in half. I don't think that really helps anybody. So thinking through how you're going to deliver the air, where you're going to deliver the air, what all those 5 factors are within the actual confines of the challenge that you put yourself into this floor plan is very important. You guys, please do comment below if you have anything else to add about the plans that I showed or your own struggle with plans. And if you want to see other things talked about in the future, just let me know. Like and subscribe. Tune in next time.